Okay, uh, so in this video I am going to explain how to solve this type of problems about experimental error, as well as showing you the formula that you are going to use in order to find the percentage of the experimental error in problems like this. Okay, so the formula of experimental error percentage is the following. Experimental value I am going to use only the V minus theoretical value sorry, I need to make it smaller, divided by the theoretical value times 100. Okay, yes, but this formula has something special, which is called the absolute value, that I am going to represent with bars here and here. Okay, that is really important for this formula, because this will determine that our result is going to be positive regardless of what quantities we have. If they are negative or positive, it doesn't matter, because the result is going to be positive. Because with these bars, everything that is inside becomes positive. So for example, I am going to write the bars here. I am going to make some things bigger. And let's say that I put -5 inside these bars. Okay? The result is going to be 5, because everything inside these bars, the absolute value of bars, is becoming positive. What happens if I put a positive number like 8? Well, it stays the same. What happens if I put -10? It becomes positive 10. And what happens if I put an operation, for example, 5 plus 3? That is 8. And as the result is positive, it stays positive. But what happens if instead I put something like, let's see, 3 minus 5? Well, 3 minus 5 is 2 negative. Negative 2, right? But as this is negative and it's inside the blue bars, the absolute value bars, it has to become positive. So you have to put it positive. Okay? So that is really important for this kind of exercise. Other important thing, let me erase this before I explain, is knowing what the experimental value and the theoretical value are. Okay? Because those are two different numbers in these problems that I am going to teach you how to recognize. The experimental value is the value that you measure. While the theoretical value is a value that you know to be more accurate, to be closer to the correct value than the other one, more accurate. Let me make it smaller. More accurate, more correct And in these kind of problems, you are going to have both of them. So let's begin with the first one. In this one, it's really simple because the only thing that you know is what those two values are. You know the experimental and the theoretical value. So let's apply the formula for the first problem, and then we will try to understand what those values are in the others. So look, I am going to be applying this formula. So what is the experimental value? The experimental value is 1.24 grams minus the theoretical value, which is 1.30. Okay, don't forget that after that we have to divide, look, division, a long bar, by the theoretical value, which is 1.30, but let's put the absolute value bars because they are important. Don't forget it, they exist there. And finally we have to multiply by 100. So let's do step by step. Let's first do the operation inside the first absolute value bars. So $1.24 minus 1.30. That is negative, sorry, let me do it with black, negative 0.06. And don't forget, it is inside the absolute value bars. Now, let's do the other part. Sorry, let me do it with red, which is the denominator of this operation. 1.30 grams. I forgot the grams here. And inside the absolute value bars. Finally, don't forget to multiply by 100. This part. Okay. So we get the new formula. Well, not the new formula, but the result of our formula. Next, let's get rid of the absolute value bars, the blue bars. Let's get rid of them. How are we going to get rid of them? By erasing all of the negatives that are inside there. So this negative has to go. It is gone, as well as the absolute value bars. So 0.06 grams. No negative, no absolute value bar. They are gone. Se fueron. Okay? And here it is positive, so we can get rid of the bars. Las podemos borrar. And remain this positive. And times 100. Look. This becomes this. Okay. What's next? We have to make this division. 0.06 divided by 1.30. Something is happening. Let me do it again. 1.2, sorry. 0.06 divided by 1.30. And that is, wow, a really big number, 0.04615, whatever. So let's only put 3 decimals, 0.046. Sorry, that's a 0, that's a 4, not a 9. Okay, remember this became this. And now we have to multiply by 100. So we have this number, and then we multiply it by 100, which is 4,615%, because the result of this operation of percentage error is a percentage. So we have to put this sign of percent at the end. And this is the result of our exercise. When the experimental value is 1.24 and the theoretical value is 1.30, the result is the experimental error is 4.615%. That is the percentage of error. Okay, and that is how you apply the formula. Don't worry, we are going to do it again with the other points, but I wanted to first show you how it's done. You can go back to any point of the video if you need to think a little bit more of this. So now let's go to the actual problems. Let's read it. At a track meet, you time a friend running 100 miles in 11 seconds. The officials time her at 10.67 seconds. What is your percentage error? So we have to identify what is the experimental error, experimental value, and the theoretical value. Okay, so remember, the experimental value is the one that you measure, and the theoretical value is more accurate, is more precise, closer to what is correct. So let's think about that. In this problem, what is the value that you measure? Let's read again. At a track meet, you time a friend running 11 seconds. That is the value that you measure, so that is the experimental value. Seconds. And the other one is measured by the officials. So that means that that is more accurate, more precise, because they probably have a better equipment to measure. So that is the theoretical value, because that is more correct. So 10.67 seconds is the theoretical value. So knowing that, we can apply the formula of experimental error. Let me write it again. Experimental value, I am going to make it shorter, minus theoretical value over the theoretical value times 100, but don't forget that this has an absolute value and this has an absolute value. So let's do it with these numbers. Experimental value 11, so 11 seconds minus 10.67 seconds over 10.67 seconds, because that is the theoretical value. Esto es una S. I am going to put it inside a square so you don't get confused with a 5. Sorry for that. Eso es una S de seconds. Okay? Don't forget the absolute value bars and multiplying by 100. Let's make that operation. Let me put the calculator in 0, 11 minus 10.67, 0.33. look, this became this. And this don't forget the absolute value bars, and also down, because down has to go the 10.67 seconds. Here, key seconds, 10.67 seconds times 100. Now let's get rid of the absolute value bars. This is positive, so we leave it positive, and the same here. So we only have to write the same thing positive. Sorry. We got rid of that. We don't need it anymore. Because it made its function, became everything positive. Now let's make this division. And after that, let's multiply by 100. Okay? What is the result of this division? 0.33 divided 10.67. And the result is 0.030. When you multiply that by 100, the result is 3.09. And that is a percentage. Ok, aquí me faltó segundos. Y al dividir ya no nos queda la magnitud. This is the result of the percentage error of that point. And that is how you have to solve this kind of problems. Remember, the most important thing, besides knowing the formula, is understanding how to identify experimental and theoretical value. So don't forget it. Experimental value is the value that you measure. You may be making a mistake, but the theoretical value is the one that you know that is closer to be correct. That is how you do it.